Hey guys, my name is Bob. Welcome to the Excel Math channel. Today I'm going to talk about finding the interquartile range. So before I find the interquartile range, let me just define what is the interquartile range. It's basically the difference between the upper quartile, alright, and the lower quartile. So the upper quartile is basically the 75th percentile. Alright, so let's say for example, if I have a data set in which the sample size is equals to 8, alright, the upper quartile itself will be the second highest value, alright, in the data set itself. While for the lowest quartile is basically the 25th percentile. So basically, if let's say, alright, same thing, I have a sample size of n is equals to 8, the 25th percentile will be the sixth highest value in the whole data sets. So as you can see, this is a very short example with regards to finding the interquartile range. I have maybe 8 sets of numbers. Let me just add one more set of numbers down here. I have 200, 150, 39, 25, 12, 7, 6, 5. So basically, how to find the interquartile range is to find what is the upper quartile. So in the case, like I mentioned just now, if the sample size for this case n is equal to 8, I will find the second highest value, and that will be my 75th percentile or my upper quartile, which is in this case. Okay, this is my upper quartile. This value itself is my upper quartile. And next thing we have to find is the lower quartile. The values for the lower quartile, which is the sixth highest value or the second lowest value, which is in this case, not the second lowest value, but the third lowest value, alright? In this case, it is the, okay, the 7th is, okay, which is the lower quartile. So after that, I will take the difference between the two, and that will be the interquartile range. So the interquartile range for this case would be equals to 150 minus 7, and that will give you 143. Another use of the interquartile range is to detect the outliers, alright, in the set of sample. So how do we go about detecting a sample is to set an upper limit and the lower limit itself. So the upper limit is just basically taking the upper quartile plus half of the interquartile range, while the lower limit itself is the lower quartile minus half of the interquartile range. So as you can see, I already completed how to get the upper limit. So based on just now the data set itself, in order to calculate the upper limit, what I have to do is to take the upper quartile, which is 150, plus half of the interquartile range, which is 143, and that will give me 221.5. So that is the upper limit of the samples. While the lower limit or the sample size basically is taking the lower quartile, which is in this case 7, minus away half of the interquartile range, which is 143. And let me just key into the calculator, and that will give me negative 64.5. So what does this basically mean? Any value that falls out of this range, alright, which is negative 64.5 and 221.5. So any values in the sample sets that falls out of this range, okay, will be considered as outliers. Alright, so this is how we actually detect the outliers using the interquartile range. Alright, so there's a very simple example of how do we go about solving the interquartile range, as well as to detect outliers using the interquartile range of a data set. That's about it. I'm Bob. Thank you for tuning in, watching the video itself, and I will see you in the next video.